Welcome to the 8th Tartarus devlog. In this video, I'll discuss Tartarus's new button capability. We'll work through the add button function signature and create various buttons with unique callback functions. We'll then glance at a draft of the Affliction application code and then see the Affliction graphical user interface come to life. Hold on to your britches. In the 7th Tartarus devlog, we looked at callback functions. I've given the timestamp entity in the top right a callback component whose function will begin executing at the 30-second mark. Conveniently, that segues us into the topic for this video, buttons which use callbacks under the hood to make changes to the game state. The callback system and component dramatically simplify interactions between an entity's components, and I think we're getting outrageously close to implementing buttons. Now, I know what you're thinking. Wow, what could possibly be more exciting than buttons? I've always dreamed of watching a devlog about them. Like we discussed when looking at picking for Tartarus Devlog 4, buttons are extremely common, and you use them on your electronic devices every single day. So, instead of dazzling you with a long-winded monologue about how buttons work, I thought we could incrementally step through the high-level code so that you can develop a mildly clear picture of what Tartarus is actually doing. But before proceeding, just a quick note. A lot of the code I'll show is simplified for your viewing pleasure. Sometimes there's just no good or convenient way to display code without its complexity getting in the way. So I took a few shortcuts to make things as digestible as possible. I consider some of what you'll see to be bad practice, so keep that in mind as we progress. I might have shared this in a previous post, but here's the obscured signature of the function that adds a button to the world. Let's step through and understand each parameter. The ECS manager is passed so that the appropriate functions can be called to add the necessary entities. Remember that with an ECS architecture, an entity is just an ID to which all relevant components belong. The second argument includes a mapping of the different shader programs. Each object to be rendered is assigned one of a handful of programs such that it's drawn correctly. For example, OpenGL can easily handle drawing basic shapes, so things like polygons and polyhedra are assigned a very simple shader program. In contrast, to show text on the screen, a font texture map is loaded and must be passed to the shader program, so textual objects are assigned a slightly more involved program. Next, the texture ID is passed. A non-zero ID specifies that a texture should overlay the button. For example, here's a very plain and basic square button. I can add the Tartarus logo to this button, or I could set it to something like this star. The next argument specifies the optional text that should appear on the button. Usually we want buttons to have either an icon or text, but note that it's possible to specify both. The next two arguments are the X and Y positions. The next two arguments are, surprise, the button rectangle dimensions. Now, I've made these buttons all with different sizes. Currently, I don't have built-in support for alternative button shapes. I tend to like rectangular buttons, but that wouldn't be too difficult to implement. However, to keep things simple, we'll stick with rectangles. The next argument is the scale or size of the text. By default, the text is loaded at 100 point size, so this number represents the fraction of 100 point to use. I haven't yet found a good way to use this property other than to ensure the text fits within each respective box. Eventually, I'll create a function that computes the appropriate text size given the dimensions of the box as well as the screen. Second to last is the component type identifier, which is another bookkeeping device to help the ECS manager keep things straight. This argument enables specifying the type of button and its underlying callback function, whether it operates on itself, another object, or whatever. Last is the actual callback function we wish to assign to the button. This is really the key argument that makes buttons buttons. Let's step through a few different callback functions and see how they work. Before getting started, I'll point out that we'll only be modifying the color of respective objects, but in principle, we could modify any component: position, orientation, size, etc. First, we might want a button that simply operates on itself. A contrived example application might be a button or item that explodes when selected. Here's the actual callback function that takes the vertex data of the calling button and modifies it to a pre-specified color. In this case, I'm just using a lambda function wrapped in a standard function. That gets passed to the add button function, which then stores it inside a callback component. Good, great, grand, wonderful. but that's boring. Let's kick it up a notch with a button that operates on another specific object, perhaps another button. Here's the relevant callback function. An example application might be something like an in-game light switch. Nifty. But what if we want a button that operates on the window itself? For example, the background color of the window. Remember, color is a stand-in for any and all other components. We could equally make a button that repositions or resizes the window. Lastly, we might want a button that operates on a selected object. If nothing's selected, the button has no effect. We could use this type of button to change some attribute of the items we select in the game world. These 4 types of buttons comprise yet another technological leap for Tartarus. The funny thing is that 5 years ago, the idea of implementing text and buttons seemed like a mountainous, if not impossible task. And now they're a standard part of Tartarus. So exciting, and just a springboard for what's next. Now that we have buttons, it'd be useful to visually organize them. The concept goes by many different names, but I currently refer to grouping background shapes as frames. For now, Tartarus frames are just colored rectangles. Sounds boring, but when you actually see how it impacts the GUI, it's a bit more exciting. Here, I've placed a frame around the buttons at the center of the window, which gives it the appearance of a menu. What's more, I can now start combining buttons and frames and functions to create entire user interfaces with a single call. For example, I've created this dummy function that creates all the buttons and the accompanying frame shown here. Now, in my main application, I can just call this function to create the menu. This is great for creating reusable layouts for buttons. You can imagine that by combining frames and buttons, we could create various elements that start to look like a graphical user interface. In fact, here's the current draft of the Affliction GUI. It's wildly unimpressive and does absolutely nothing. But if you compare it to the draft shown in Affliction Devlog 0, you'll see that the design schemes are strikingly similar. Obviously, there's still a lot of work to do, but we're inching, or, for most of the world, centimetering closer. Okay, we've got buttons and frames that can be combined to create heads-up displays. Let's zoom out a bit more and look at how the Affliction code calls Tartarus to create this primitive application. Now obviously there's a fair amount of code behind the scenes, but here's the application's source file. The run application function just gets called all by itself in the main function. We start up top with the relevant imports. At the moment, there are several Affliction-specific pieces of functionality that I'm calling, so those are wrapped in their own classes and functions to simplify this file. But you can see here, for instance, that the Affliction window is just calling the Tartarus window functionality with specific arguments. The same is true for pretty much all these other Affliction imports. They're just Affliction-specific implementations of the various tools that Tartarus provides. But I can tell from your silence that you don't believe me, so here's another example, the Shader Manager. Once again, it's just using the built-in Tartarus tools to configure a few application-specific details. Nothing exciting. Next up, I create a constant object, which turns out to be a string, and initialize it with a value that's specified at compile time. This string is a path to the directory where relevant resources can be found, including things like textures and shaders. Here's Affliction's CMake file. There on line 2, you can see where the resource dir variable is set, and lines 42 through 44 make that variable available at compile time. Hooray! We then get to the body of the run application function. First, we create a window using the aforementioned Affliction window functionality. It's critical that this step goes first because it creates the necessary OpenGL context, which is required for correct operation of pretty much everything after. From that, we retrieve the window dimensions assuming they remain constant, which will be true for this demonstration. Then we create the shader and texture managers, which use the aforementioned resources directory to load relevant resources. The ECS manager is also initialized, and it uses another Affliction-specific function that registers the relevant component types, systems, and so forth within the manager. I then configure the GLFW window user pointer to point to the ECS manager so that the ECS manager can be used inside GLFW callbacks. Next, a few critical entities are created. Remember, within the ECS architecture, anything and everything can be treated as an entity. Here, I create both the camera and the cursor used to interact with the game world. Since these are entities just like any other button in the GUI or object in the game world, In principle, they could be subject to the laws of physics or something like that, but for now, they're exactly what you'd expect. The last line calls another Affliction function that sets up the heads-up display with buttons and frames. Lastly, we peer inside the infinite loop that continues as long as the window isn't flagged to close. First, we update the rendering systems corresponding to bodies, object-oriented bounding boxes, and text, followed by the picking system. Significant values are passed to each via their own system arg structs, which is mainly a vehicle for specifying the relevant system and component IDs. Aside from these arguments, many of the systems have overlapping data requirements. The camera determines how the scene is drawn, as do the window dimensions. The window is then updated, and the loop repeats. And with that code, the following application is produced. It's simple, plain, perhaps even boring for the time being, but so was rocket fuel until we learned how to use it to travel to the moon. But in case you're still wondering whether this actually has any significance, here's the same application with a few working buttons. This button adds a cube, and after I select it, these buttons translate the selected object. Below, these buttons rotate it. Unsurprisingly, these buttons adjust the red, green, and blue components of the selected object's color. And I can continue adding cubes until my computer runs out of memory. But hopefully you can see that this gets us a lot closer to building a game world, adding, positioning, and changing characteristics of objects. After finally getting this devlog released, I'm focusing on geometry. In particular, I want to be able to start adding basic programmatically generated shapes to the world, cubes, spheres, and so on. Before I do that, I need to build the appropriate machinery to deal with meshes and things like that. I mentioned previously that I spent a lot of time looking at various algorithms for triangulation and whatnot, so I have lots of ideas I want to implement. Once complete, these geometry tools will make it really simple to start adding objects of various shapes and sizes, be it buttons or other game world entities. Look out, we nearly have ignition. Thanks for watching. If you enjoyed this content, I'd appreciate a like and your subscription if you want to stay up to date on this devlog series. As usual, please feel welcome to leave your ideas and suggestions on what features or content you'd like to see in a future devlog video. Until next time, remember that humility isn't thinking less of yourself, it's thinking of yourself less.